Hello, everyone. This is Brandon here, giving you a breakdown of Hey, everyone. Sorry again. I had to pause the recording for a second. This is Brandon, and I am going to get started with connecting to an existing Micro 820 PLC by Alan Bradley. So this is going to be for the PLC 3 class for a project we're doing. We're actually going to be using a Micro 850 controller to make a homemade troubleshooting station. But for the time being, I'm just going to show you how to connect to an existing Micro 820 and or 850 or 800 PLC. So I got my Ethernet cables already hooked up and ready to go. I've already preset my computer configurations to meet the IP address. So as with all Micro 800 PLCs, it uses a 169.254 IP address. So if I go into my command prompt to verify that it is set, I'm going to type in IP config, hit enter. And as you can see, my secondary network card, I have an IP address set for 169.254.1.1 to meet that 169.254 range. And then I have 255.255.0.0. The 255 and 255 just means that those numbers up here have to be an exact match. And the 1.1 and 0.0 mean it could be anything in those number ranges, ranging from 0 to 255 or 1 to 255. So I'm going to close out this command prompt and go into Discover. This is what the starting page will look like for the Connected Components Workbench. So if I hit the Discover button here, it's going to bring up this menu here for RS links for the connection browser. And I'm going to find my Micro 820. Looks like we got her right here. So this is our Micro 820, the 169.254.63.18. Just going to hit this OK button, start connecting to it. And we are almost there. Forgive me for the computer being a little bit slow, but that's kind of just the way it is. So here we are. It's going to pull up the processor and it's uploading from the PLC itself. And there is an existing program on here because students have been tinkering with it as well, but we'll go ahead and delete some of those and just stick with one program to kind of go over some basics. So this is just a general breakdown of the controller. This is what the Micro 820 looks like. These are your parameters, what version number you have, and all that good stuff. And we're in remote run mode. So as I've said before, with the Micro 800 series PLCs, you need to be offline to make your changes. So as you can see, we're connected. If I double click on the programs, you'll see some of the programs the students have just been tinkering with, and it has to go through and open each individual file. So here's some of the ones they've been building using compare functions, counters, and just your standard inputs and outputs. So what we're going to do here is let's go into program one and see what this looks like. It's got a timer, a couple of timers, a couple of counters. So what we're going to do is we're just going to stick with program one at this point. So I'm going to go ahead and get rid of, I'm going to disconnect. I'm going to get rid of program two and program three. And again, you always have to disconnect. And by right-clicking on the program number, you can just delete it. So now we are in program one. And I'm going to give you a general breakdown of what this is doing. So we have toggle switch one that we have here, and then we're going to a timer. And that timer, it's 3 seconds. It's going to turn on our blue light, and then our blue light's going to start another timer that is 9 seconds. I don't know why they would make a 9-second timer, but then that timer done is going to turn on our blue light again. I don't know. I didn't make this program. Some students were just tinkering with it. So I'm kind of curious to see what this program does. So I'm going to go ahead and connect again. Then I'm going to download the current project to the controller. Remember, in PLCs, if you want to download changes or want to save changes that you've made when you're offline, you have to download it to the controller. If you upload, you're going to pull the existing program and overwrite it. So I'm going to download with project values. Sorry, I'm sipping on my coffee. All right. So we're getting there. We've successfully downloaded one program. We get the little notification down here that it is downloaded, and it's going to be connected here soon. Do you want to change to remote? Yes, I do. So I want the program to be online so I can see what it does. Again, this is just more of a spitball video. This isn't really a tutorial. Just going to show you how to tweak things and how to do a few things as well. So if you think this is more of a tutorial on timers or counters, maybe a little bit of both. But that being said, we're online with the program. Let's see what it does. Toggle switch 1. I'm going to flip that on my trainer. And that's going to start the timer. And then my blue light came on. And then after 9 seconds, my blue light went off. So apparently this is a latch and unlatch sequence here. Got it. So that was a real basic in CCW. Your S will be like your latches and your R's will be like your unlatches in Studio 5000. But this is Connected Components Workbench version 12. So we use S's and R's. So that basically my toggle switch started a timer. The timer turned on the blue light. That blue light energized this timer for 9 seconds. And after 9 seconds, it unlatched my blue light. So do that one more time. Now I've reset my timer values because I turned my toggle switch off. I'm going to turn it back on in 3, 2, 1. And we're going to go through the same sequence here. My blue light is now on. And then after this timer reaches the 9-second preset value, it will energize this, thus unlatching it. And now it is off. Now you can see neither one of them are red or energized, as we call them. So yeah, they just built a basic sequence event that causes the blue light to turn on after a certain amount of time and then to turn off after a certain amount of time. So now I'll turn that off. Now my toggle switch is off. Now I want to see what they did down here. They used the green push button on the trainer, or input 3, digital input 3 is listed here, to turn on the yellow light. So what I'm gathering is if I push this green push button, and every time I turn this yellow light on, it counts up. So our preset value is 3. So once it reaches 3 on that counter value, our red light should turn on. So I'm going to hit the green button. I did it once. And as you can see, our counter value went up. I did it twice. As you can see, it went up again to 2. Then I pushed it 3 times. And now after 3 times, my red light comes on to indicate that, yes, your output 3 has been turned on 3 times, because now our preset value meets, or I'm sorry, our counter value now meets the preset value. So as you can see, you're using Qs instead of .dns, and you still have the same CU, which is for your count up. That's where your input's coming in. Your resets, however, for your counters work slightly different in Connected Components Workbench. So you see how we're using digital input 3, which is our green button, to turn on our yellow light. And we're using like digital input 1, which is our first toggle switch, input 1 on our trainer, and to start this timer. But we're also using digital input 2, which is our second toggle switch. As you can see, alias is toggle switch 2 that popped up there momentarily. And if I push this, what that does is you can see our counter reset is false. By turning on our toggle switch 2, it will change it to true and it will reset the counter. So I'm going to do that in 3, 2, 1. So as you can see, I turned it on, changed to true, and our counted value has changed to 0. So I turned the toggle switch back off, and now I hit my green button again, 3 times. There's 1, 2, 3. Now yellow light has been on 3 times, and now red light is on, showing that it's been on 3 times. I'm going to do toggle switch 2 again, and it reset the counter value, thus turning off the red light, because now our counted value is 0 instead of 3, which we can't be queued unless we have met that preset value. So that's just going over a very basic CCW program, like I said, that was built. Kind of want to go over a couple other things you'll see over here in your project organizer. You have your local variables, which are designed specifically for each individual program. And then you have your global variables, which will be the ones that are tied to the PLC specifically, whether they've been created or they're just part of the inputs and outputs. So you'll have your output 0, output 1, output 2, output 3, output 4, and it has the alias along with them. So obviously output 1 is your blue light, green light, yellow light, and red light. And those are something that we have to purposely give them ourselves. Then we have digital input 1, 2, 3, and 4 as toggle switch 1 and 2, and your green push button and red push button. That's the way that these were designed in the PLC specifically. One of the reasons why we just meant to keep the switch 1, switch 2 lined up with input 1, input 2, you'll notice input 0 isn't being used, and that is for a very specific purpose. Input 0 is, I think, used as a analog input as a standby for us later on. But again, it's just something that the way that we've designed this trainer, the way this trainer was designed by the PLC cable crew, that is exactly what it's for. So if we scroll down here, you're just going to see a couple little variables here, keeping track of timers, the amount of time it's on. You'll notice the statuses are changing over here in logical value. And then we've created some math inputs and some counters. Notice counter 1, 2, 3. If you expand it, you actually have this kind of the same values as you'd see in Studio 5000 with your count up, the reset, the preset value, the Q, which is like the .dn, the counted value. I mean, there's not really a whole lot more to kind of go over. Again, this is a basic broad stroke overview of an example program and how to kind of look at your variables and your inputs that have been created for this program on this PLC trainer. And again, the trainer just has 4 inputs and 4 outputs that are wired in. One of the things, if you're watching the logical value here, if I let's see, no, that's not working at the moment. So we'll ignore the analog one. I'll have to reconfigure that one, and we'll go over that later. But you have some comments over here as well. I always like to make comments when in doubt, comment out. The reason for that is so you can kind of keep track of what these are designed for. And it specifically tells you in the comments here, programmed cycle time. Right here, you have your system variable cycle time. So just know, make sure you leave comments. Make sure if you have a physical input that is wired in, make sure you assign an alias to it. So when you're typing it in the program, it will actually let you know what it is. Obviously here, push button green, it's a dead giveaway. Yellow light, dead giveaway. So again, I just wanted to go over some basic structural differences between the CCW software and Studio 5000. Once we start building our own trainers, you'll be very thankful you have this kind of video as a resource. And again, make sure you look up plenty of other resources available on YouTube. There are plenty of project examples, as well as connect to the skill loss trainer that we have over here behind me and watch the program run live so you can get an idea of how the CCW software can be built to actually run a piece of equipment. Anyway, hope this has been helpful, and I'll holler at you guys later.